Let me also argue that energy access, providing energy for the people who don't have access today, also requires you to rethink the way in the structure of your energy economy. We've always planned an energy economy in terms of large centralized generating stations, large grids, in fact, going to projects which have become larger and larger, ultra mega projects, 4,000 megawatt thermal plants, gigantic hydro plants, and so on. Highly centralized generation, large-scale grid distribution. And the reality is that if you look at grid-based electricity, it basically bypasses large numbers of households. In my country, 400 million people don't have access, don't use electricity. They don't have access to electricity. Decentralized electricity is an increasingly viable option. We went in for scale because we thought in terms of economies of scale, but there are basic transformations of technology which are taking place. Small turbines are now quite efficient. Really small turbines, even turbines that you put on top of trucks. There's talk now of putting turbines, little small mini turbines, so that when the truck is moving down the road, it generates a little electricity also. There is, of course, small turbines which are put into canals and things like that. Distributed generation with smart grids, which allow a much better matching of supply and demand. The greater, in many places which are distant from potential fossil fuel-based sources, renewable energy, to go to the Sundarbans in India, the delta of the Ganges. There are people, there are youngsters there, who think electricity only comes from solar panels. They've never seen electricity come over the grid to their house. They think that electricity is something which comes only from solar panels, because that's the only way you can supply electricity to those households out there. So even from the perspective of energy access, I would argue that we will have to rethink the way in which we design our energy economy. Now combine this with the growing concerns about climate. This is a challenge even if you forget about climate. Simply from the perspective of energy security and energy access, we need to rethink how we manage our energy economy. Now bring in the factor of climate, the stuff which is being discussed in Durban. Yes, of course we are right to argue about historical responsibility. Of course we are right to argue that we have to give primacy to development. But we also have to accept that the consequences of climate change on our tropical countries, which most of our developing world is in the tropics, is far greater than what it is going to be in the temperate zones. So it is in our interest to get strong action on climate. What is the action that we need on climate? Again, I'm not going to try and get into details here, but roughly speaking, what I find convenient and helpful here is to say that basically if you look at the recent UNEP report, Bridging the Emissions Gap, you can say that what we need to do between now and 2020 can be realized largely from two things: energy efficiency and forestry. Beyond 2020, renewables will have to play a much bigger role. And beyond 2030, I have no idea as to what it would be. We have no notion on what will the shape and how the energy economy will evolve in that period. It's the stuff which is going to need blue sky research. Just to give you a sense of the scale, if we were to achieve what IPCC would like us to achieve, between now and 2050, carbon emissions have to halve, go down by 50%. Global GDP will be about 5 times larger. That means carbon productivity will have to be 10 times larger. 10-fold increase, not 100%, not 200%, it's 1,000%. A 10-fold increase in carbon productivity is what the numbers require. It's a scale of transformation of energy use which is comparable to the increase in labor productivity of the Industrial Revolution. And just as that change in productivity led to profound changes in society, in urban pattern, I would argue that this transformation of the energy economy, if it takes place, and it has to take place if we want to avert the worst risks of climate change, will lead to an equally dramatic transformation of society, of urbanization, and so on. But that stuff is beyond 2030. As it stands now, the immediate gains are in terms of efficiency, forestry, and renewables. Already a lot is happening in this area. On efficiency, because of a variety of pressures, there is a tremendous amount of work which is being done. There are huge gains in efficiency which have been secured in many developing countries. But take renewables. You know, last year, according to the Bloomberg data, investment in renewables exceeded the investment in oil and coal and gas-based power. 187 billion was the investment in renewables, and 157 billion was the investment in oil, coal, gas. These numbers exclude pure replacement investments. These numbers also exclude large hydels. The renewables is only solar, wind, and small hydel, and a little bit of geothermal and a few other things. Already, the scale of investments in renewables is getting competitive in terms of scale with classical fossil fuel. Maurice Strong spoke to you about China and the scale at which they are going in for solar and wind. In India, I've been involved a lot in the low-carbon group in India, which the government had set up. And what I saw was that the pressures now for, say, an ambitious solar program or an ambitious wind program no longer come from green groups. It comes from industry, who smell opportunity here. They are the ones who are pressing the government for a much more ambitious solar and wind program, not green groups any longer. The renewable energy economy is changing. In fact, I personally think it's changing too fast because it's very subsidy-driven. Very subsidy-driven. It's about, the subsidies for renewables exceeds about $60 billion right now. And I don't know how sustainable all this is. Maybe what we really need now is to establish viable business plans. And the time when renewables will have to come into their own is a period beyond 2030. Now, the great opportunity here for the developing world is 70% of my country, 70% of the infrastructure in terms of buildings, in terms of cities, in terms of transportation, which will exist in 2030 has not yet been built. 70 to, not more than 70 to 80% of the infrastructure, energy-using infrastructure which will exist in 2030 has yet to be built. And you have a huge opportunity in this context for designing this so that it meets some of these concerns about the transformation of the energy economy which will have to take place over the next 40 years, looking at the mid-century perspective of the IPCC. And this is the opportunity which I believe is there for developing countries. Because this is going to be the driving force of growth and development in this century. If production grows, a radical transformation of production was the theme of the 19th century. If you look at how steel and or textiles were produced at the beginning of the 19th and the end of the 19th, you see the scale. If consumption growth was the driving force of the 20th century, you just look at how many people had a watch or personal vehicles at the beginning of the century and how many had it at the end, or for that matter of telephones. Then I would argue that in the 21st century, the huge difference you'll see is in the efficiency of resource use. And this century will belong to those countries, corporations, entities, which establish a presence in these technologies of resource efficiency. And this is the opportunity which I believe is there. So, to summarize, our domestic developmental compulsions require us to rethink our energy paths, just from the perspective of energy security and energy access. That it ties in with what could well be a global development driven by the concerns about climate, focusing on issues of efficiency, and that this, therefore, can become an opportunity where the developing countries can become leaders of development and not just followers. This is the sense in which I gave my title as Energy Futures, constraint or opportunity. Yes, it is a constraint. We don't have the option of cheap energy that the West had. But that constraint can be made into an opportunity because the whole world will have to go in for these efficiency methods and technologies, the alternative non-fossil sources, and so on. I believe there's much more to this than simply technology. I think, for instance, the shape of our cities is going to be completely, I cannot even imagine what it will be like. Liquid fuels will virtually be unknown in 2050. Our mobility patterns will be different. A much larger proportion of our energy use will be mediated through smart electricity systems and so on. Now, nobody knows what this is, and this is where blue sky research comes in. This is an area where we perhaps have to do much more in the developing world. On the blue sky research for shaping the energy economy to 2050, where we really do not know what shape it will actually have. So my plea today is that let's get out of this notion of seeing this simply as a constraint. Let's get out of this notion that this is we are victims who are meant to suffer. Let us see this as an opportunity which allows us to reclaim some of the space that we had at one time in the global system. This is basically what my take is on the idea of sustainability from the perspective of energy. So maybe I'll stop at this point. Thank you.